So hi and hello. Welcome to our channel named Elko Exploration. My name is Samir. Now in today's lecture, we are going to see that how to find the subarrays. Okay. So I have shown this concept in many lectures. In many of the problems, we are going to find the subarrays and its sums. So I thought that I'll be making a separate video on this. Okay. So that I can refer in many videos in future. So let's take one array 1, 2, 3, 4. Okay. Now, if I talk about a subarray, the definition of the subarray is that it is a part of an array in a continuous order. Okay. And also it can be a single element. Also, a whole array can also be called as a subarray. Now, if you try to find the subarray starting from 1, it can be 1, 2, 1, 2, 3, 1, 2, 3, and 4. Now, if we think about starting with 2, it can be 2, then 2, 3, 2, 3, 4. Also, it can be 3 and 3, 4, and at last 4. Okay, so these are the subarrays. Now, if we talk about how many subarrays can be formed when the size is 4, here it is 4, then 3, then 2, and then 1. So 4 plus 3 plus 2 plus 1, this will be 10, right? Now, when this size of an array is 4, the number of subarrays we get is 10. Okay, so if you talk about this 4, then 3, then 2, then 1. Okay, let's say if the size of an array is 5, then initially the the number of subarrays starting with the first element will be 5, then 4, then 3, then 2, then 1, right? So this is nothing but a sum of the natural numbers, right? So when the size of an array is n, okay, we will be getting n, then plus n minus 1 plus n minus 2 and so on. So it is nothing but a summation formula. So n into n plus 1 by 2. So this is a formula for finding how many subarrays can be found when the size of an array is n. Okay, now let's see that how we can find the number of subarrays. See, I'll be in this video, I'll be keeping this approach a very brute force. That means I'll be explaining you in a brute force way. That is, first of all, we will be going to have two pointers, S, okay, and then E. Let's say, for example, now after that, we are going to iterate from S to E. Okay, so this is the idea. So first of all, we are going to have one for loop in which I will be running from 0 and it will be gone till n. Okay, inside this, we are going to have a start variable. Okay, and I'm going to initialize to I. Now we are going to have one more for loop which will be j, which will be starting from I only, because a single element can also be called as a sub array and it will be contain n. Now inside this for loop I'm going to have end variable. Okay, inside this I'm going to have, sorry, the end value will be j. Now after that, let's say start is here, end is here. Okay, now I'm going to iterate from start to end, in which these all the values are going to store in the external array. Okay, so for k, which will be starting from I, sorry, start, which will be starting from start, and it will be gone till less than equals to end. Okay, don't forget that, less than equals to. Now inside this I'm going to either print all the subarrays, that is, let's say start is there, end is there, I'm going to print, or I'm going to store it. So you can think about how we can store this array in an auxiliary array, but here I'm going to just simply print it. So print a of k. After that it will be fill space. Okay, after that I'll be simply going to print a new line. That's it. Okay, So this is a brute force approach, or we can say brute force manner to print all the subarrays. Okay. Now the thing is that, let's say if I want to find the sum of each and every subarray, how we can change this pseudocode to find its sum. See, for this, the sum is 1. For this, the sum is 3. For this, the sum is 6. And for this, the sum is 10. For this, the sum is 2. For this, the sum is 5. For this, the sum is 9. Then we have 3. Then we have 7. And then we have 4. Okay. Now we want to have this array, okay, in which the size will be this. Why this? Because we are going to find the sum of every subarrays. Okay, so size will be this. Now inside this array we are going to store these values, sum of every subarrays. Okay, now there are multiple approach. Okay, but since I told you that I'm going to have a brute force, so I'm going to simply modify this pseudocode to have the sum. See, first of all, the start and end will be same. Therefore, the two for loops are going to be same. For I will be going from 0 to n. The value of start will be I. For j will be going from I to n. Inside this, the end will be j. Okay, now we got 2 pointers, start and end. Now we are going to have one more array, sorry, one more for loop in which the value k will be going from start to less than equals to end. Now inside this I'm going to store this sum on the go. So sum plus equals to a of k. That's it. And after that, let's say the array size result dot add sum. That's it. Now here I'm going to have sum is equals to 0, because after every third iteration the sum should be 0, then only we will get the sum of every subarrays. I hope you got this. If you talk about the space complexity, sorry, if you talk about the time complexity, it will be simply order of n cube. Why? Because in both this pseudocode there are 3 for loops in which each of them are approximately going for n times, right? So n into n into n leads to n square, n cube, sorry. Now if you talk about the space complexity of this, it will be constant. And if you talk about this, someone might say that here we are going to have the extra space, right? So see this. Now what will be the size of this result array? Okay, it will be simple this. Now if we talk about this n square into n by 2, right? And if you talk about the dominant term, this is n square. So someone might think that the space complexity will be order of n square, but I'll say it is wrong. Why? Because they want the answer in a array format only. Okay, so we are not actually using the extra space to solve our problem. We are having that extra space to give that answer, right? So the space complexity will be constant only, not n square. Okay, I hope you got this. So in the future videos, if I talk about defining the sub arrays, then I'll be referring this video. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing.